Hello and welcome. For today's video we are looking at calculating electrical power, and we are going to look at two formulae in order to work that out. The first one here is P equals E over T. Now we've come across this before in our forces and energy video that I've done in the past. So it's the very same formula. It can also be applied to electrical circuits, but just in terms of a recap, let's have a look at what that means. We've got P equals E over T, and that just basically means power equals energy transferred over time. Now this much you'll be given in the exam. You'll be given a formula sheet which has this formula on it. You'll be given the letters and the meaning of those letters. What you won't be given is the units, which we'll look at in a second. If you want a copy of the formula sheet, you can go to my-gcsescience.com, and if you go to the additional science page, next to the title of physics, there's a link to help you or to direct you to download that. You can also get it off the AQA website, but it's a little bit trickier to find on there. Either way, that formula sheet is available. Now we have P equals E over T. Power is energy transferred over time, but as we said, we don't have the units given for this formula. So for power, it's watts. Energy transferred, it's joules. And for time, it's seconds, and the abbreviations for those are as follows. So capital W, capital J, and small s, and you should actually remember these units because those won't be given to you. Now, just as a little way of remembering what this all means without using the formula, when we say energy transferred over time, or when we say watts, we mean joules per second. So imagine we had a light bulb here with a 50-watt power rating. What that basically means is that it transfers 50 joules of energy per second. So every second that passes, 50 joules of energy are transferred to the surroundings. That's what we mean by the word watts, joules per second, and it always involves a time scale. Now if we were to take that one step further, imagine we had a very similar lamp, but this time it wasn't transferring 50 joules per second, it's transferring 100 joules every second. That just means 100 joules per second. Joules per second means watts. That means this is a 100-watt light bulb. It's probably going to be quite useful to remember the idea that watts and joules per second is the same thing. The next formula that I want to look at goes like this. Power is potential difference times current, or P equals VI. Again, these two you'll be given in the exam. You won't be given the units, but before we go on to the units, I would like to remind you of the following. This idea of potential difference means energy transferred per coulomb. So every coulomb of charge that passes a point transfers a certain amount of energy, and we call that amount of energy the potential difference. The current means coulombs per second. So a certain number of coulombs passes a point every second, and each one of those coulombs transfers a certain amount of energy, and if we know those two values we can work out the power. Okay, but just to go back to a slightly simpler version here, we've got P equals VI, and the units are very simply as follows. For power it's watts, as we know. Potential difference, or voltage we can call that, is volts, and current is in amps. The abbreviations are again W, V, and A for amps. It's probably worth now looking at a couple of examples. So here we have two questions. The first one on the left hand side says a microwave oven transfers 7,000 joules of energy in 10 seconds. Calculate the power. So we need to decide firstly which of those two formulae we're going to use, and if we look at the question, there's clues in the question. So it says transferring energy, so we've got 7,500 joules of energy being transferred in 10 seconds. So that really should lead us to P equals energy transferred over time, because those are the two values that we have. And very simply then it's a case of plugging in the numbers. So it's 7,500 over 10, which is 750. So our microwave oven has a power rating of 750 watts. Okay, so that's 750 joules every second of energy that is transferred by the microwave oven. So the next question here, a loudspeaker has a potential difference across it of 120 volts and a current of 0.5 amps. If you're thinking ahead, you probably got this already. It's the other formula, is power equals potential difference times current. Again, remember you'll be given these, so you won't have to remember them. But that's just a simple case of 120 times 0.5. So the power of this loudspeaker is 60 watts. Okay, so just one last quick example. Maybe you want to have a go at this one. Here's one that's shown in a diagrammatical form. See if you can figure out which formula you're going to use and what the answer is, and I'll go through the answer momentarily if you're giving this a go yourself. So which formula do we use? Well, we've got a potential difference here and we've got a current, so again it's going to be P equals V times I, and very simply 230 times 1.5, which is 345, I believe, watts. So the power for this is 345 watts. Okay, so there's those two formulae that you need to use. Make sure you're fairly clear on how to use them. Other than that, that's me done for this video. Thanks for watching, and I'll see you again soon.